Hello, everyone, and welcome to section 3.4 in Precalculus, Exponential and Logarithmic Equations. Today, we'll be taking everything that we've learned all chapter and using it to solve equations. So we've already learned these two things. The first one says that a to the x is equal to a to the y if and only if x is equal to y. So that should make some sense to you. If you have 2 to the x and then somebody else says, I have 2 to the 3, x must be equal to 3. It's the only way it would make sense. So we can use that to solve an equation like this. We have 2 to the x. If we can figure out that 32 is 2 to the something, then we'll know what x is. And sure enough, 32 is 2 to the 5th. Therefore, remember this is our little notation for therefore, x is equal to 5. The same is true for logs of any base. If I tell you that I have log base 8 of 12, and that's equal to log base 8 of y, then y must be equal to 12. So I can use that on this one. I can add the natural log of 3 to both sides, and then I have the natural log of x is equal to the natural log of 3, so x is equal to 3. This is a great method, but we almost never have the same base. So I am going to spend most of the day teaching you how to do the problems where it's not going to be quite this easy, although I'll throw a few of these in there along the way. And if you catch them, by all means, you should do them that way. So the main way that we're going to solve these problems is by undoing things with an inverse operation. You've been doing this literally for years. If you have x plus 4 is equal to 7, what did you do to solve this? You subtracted 4 from both sides, because subtracting is the inverse operation of adding. If you had 3x is equal to 9, what did you do to both sides? You divided, because division is the inverse operation of multiplication. If you had the square root of x is equal to 21, what did you do to both sides? You squared both sides, because squaring is the inverse operation of square roots. So for us today, how do I get rid of an e? With a natural log. The natural log of e to the x is equal to the natural log of 7. I can actually take the natural log of both sides. On this side, you may remember that the natural log of e to the x is just x. And there's my answer. X is equal to the natural log of 7. Conversely, if you have a natural log, you can undo it with an e. This process is called exponentiating. That means I'm literally making the equation into the exponent part of the equation. So think about that. If I have e to the something is equal to e to the something else, then those two somethings must be equal. Now I'm reversing that. I'm starting with the two somethings that must be equal, and I'm making them into the exponents. That process is called to exponentiate. Why would I do that? Because e to the ln of x is just x. So now I have e to the negative 3, or you could write it as 1 over e cubed. Now, sometimes you can't see what the base is, so remember that if you can't see it, it's base 10. So again, I'm going to exponentiate 10 to the log base 10 of x is equal to 10 to the negative 1. So if you weren't fully grasping this in the last couple sections, you really need to get it today, that if you have a base 10 and then a log base 10, they undo each other. So on this whole side, that becomes x. And on this side, I have 10 to the negative 1, which is 1 over 10 to the positive 1, which is just either 1/10 or 0.1. There's so many ways to write the answer. I'll take any of them. They're all great answers. On this one, I see an e, so I think to myself, I'm going to do the natural log of both sides. Natural log undoes e. So the natural log of e to the negative x squared is equal to the natural log of e to the negative 3x minus 4. The natural log and the e cancel on this side and leave me with just negative x squared. The natural log and the e cancel on this side and leave me with negative 3x minus 4. So this is one of the ones where if you had thought it through in the beginning, you might have actually skipped to this step. You might have said, hold on, they have the same base. I can go back and use that very first property she told us, that if they have the same base, that I can make their exponents equal. So that's exactly what this is. Same base. I could have skipped right to negative x squared is equal to negative 3x plus 4, and that would have been fine. In either case, we have this equation now. I see an x squared in my equation. What do? I set it equal to 0, and I factor. If I can't factor, I'll have to use the quadratic formula, but factoring would be my first choice. The first times the first makes the first. The last times the last makes the last. I usually start with the two numbers that are closest together, so I try 2 and 2 before I try 4 and 1. But that either gives me a 4x in the middle if I add them, or a 0x in the middle if I subtract them. So it's not 2 and 2. So sometimes factoring is a little guess and check, but the more you do of it, the better you get. So this makes a 4x and a 1x, which if the 4 is negative and the 1 is positive, will give me my middle term. That's how you factor. Now that I have it factored, I can finish solving it. So if you have two things being multiplied to make 0, one of them must actually be equal to 0. And that would happen if x was equal to 4 or negative 1. So that's the basic setup for these problems. You do sometimes have to do a little work first. So in this case, you really want to divide by 3 before you try and undo that 2 to the x. So 42 divided by 3 is 14. And now, how do I undo a base 2 with a base 2? Think about that. I need to undo this base 2 with a log base 2. I do it on both sides. And now I have x is equal to log base 2 of 14. Now, just a little warning, your book is going to write it differently. Your book answer is going to be x is equal to ln of 14 over ln of 2. You may remember that that's how you would, back in the olden days when we didn't have the ability to do log of any base on our calculator, we had to do log of 14 over log of 2, or natural log of 14 over natural log of 2. Both would work in order to actually arrive at this answer. So that's how they'll write it. You're more than welcome to leave it this way. You don't have to do that. But I didn't want you to be confused when you saw it in the book. Of course, if that ever happens to you, you can always check it by figuring this out as a decimal, which would be 3.807, and then seeing what this one is. And when you see it's also 3.807, then it would allow you to say, oh, it's the same answer, they just wrote it differently, even if you don't understand why they wrote it differently. So hopefully you're getting the hang of this. If you are, I'd love to show you the next few answers and see if you can come up with them on your own. You can't quite see number 10. It is on this page. We'll do it together. There we go. 3 to the x plus 14. The answer is 2. Okay. I'll give you just a second to write those down. Okay. So remember, your first step is always to isolate, like you would with anything. Getting the x alone, getting the x squared alone. We're going to get the e alone. And now to undo an e, use natural log. So when you hear me say something like that over and over and over again, that lets you know that that's probably a really good thing to write in your appendix. When you see an e, undo it with a natural log. If you would like to have this as a decimal, please round to 3 decimal places. That way it's pretty accurate. On number 7, every once in a while a kid has trouble finding what it is we're trying to isolate. But it is this piece right here, this 3 to the 2t minus 5. That's my exponential part. So let's get that all by itself. I'm going to add 4. Make sure you keep your notation here. And then I'm going to divide by 2. And now I need to undo that exponent. So remember, logs and exponential functions are inverses of each other. So if you have a base 3 with an exponent, you need to undo it with a log base 3. So log base 3 on both sides of 3 to the 2t minus 5. Log base 3 of 15 over 2. See how I did log base 3 on both sides? Because on this side, the log base 3 and this base 3 cancel each other out, and I get 2t minus 5. Now at this point, you might just switch that to 7.5, just so it's not quite as clunky there. And now I can add my 5 to both sides. Notice that I'm going to put it before the log, just so that you don't accidentally add it to the 7.5, which would be pretty easy. So putting it on the back side might cause you to write 12.5, which would be incorrect. And then finally, t is equal to, you can either write 1/2. You can multiply both sides by 1/2 to get it. Or if you're thinking, I don't know how she did that. So I'm multiplying both sides by 1/2. Or if it just makes more sense to you, you can do 5 plus log base 3 of 7.5 all over 2. That was just a little funny because you've already got a subscript. So then doing division seems a little tricky. Or you can type the whole thing into your graphing calculator and get it as a decimal. Again, 3 decimal places would be great. So any of these answers are really wonderful. So we undo a log, an exponent with a log. We're going to undo a log with an exponent. If it's a natural log of x, then we undo it with the e. So I'm going to make these the exponents now. I give them the same base, but now natural log of x is equal to 2 as an exponent. On this side, e to the ln of x cancels, and I get x is equal to e squared. On this one, I'm going to raise them both, exponentiate them with a base 3. Whatever you do to one side, you have to do to the other. And the 3 as a base for the exponent and a 3 as a base for the log cancel each other out, and I get 5x minus 1 is equal to x plus 7. Good for you if you saw that you could have gone this way directly. Whenever you have two logs with same bases, then the insides must be equal. So you didn't actually need to do this step, but I wanted to show you that either way is going to work. And then at the same time, I can subtract x and add 1. X is equal to 2. All right, number 10 is the most important problem of the day. Do not exponentiate individual terms. I cannot stress this enough. And as much as I said this, somebody is still going to do it. It's going to be very sad. Meaning people put a 6 here and a 6 here and a 6 here, and then they write 3x plus 14 minus 5 is equal to 2x. No, I cannot stress enough. That does not work. You can only do it to a side. So just think about that. 1 plus 2 is equal to 3. Agreed? But is 2 to the 1 plus 2 squared equal to 2 to the third? No. 2 plus 4 is not equal to 8. Okay, it doesn't work that way. Oh, but hold on. 2 times 4 is equal to 8. Why is that? That's because we can rewrite this. Last class, we learned how to condense. We can rewrite this as log base 6 of 3x plus 14 divided by 5, these are being subtracted. I can make it into a single logarithmic expression. Log base 2 of 2x. Remember, logs are related to exponents, so their same rules apply. And now that I have this, I can change it to 6 to the log base 6 of 3x plus 14 over 5 is equal to, oh, I'm sorry, this is a log base 6. I have a little 2 there. I'm just going to erase it real quick. Is equal to 6 to the log base 6 of 2x. The base 6 and the log base 6 cancel each other out, and I get 3x plus 14 over 5. And on this side, the log base 6 and the exponent base 6, they cancel each other out, and I get 2x. Now, this is still a hard problem because it has a fraction in it, so our first step is going to be to clear that fraction. I would love for you to walk away from this year saying, I'm not afraid of fractions. I can clear them away. And now this cancels, and I get 3x plus 14 is equal to 10x. 14 subtracting 3x from both sides is 7x, and x is equal to 2. But the place that everybody goes wrong is right here. They just think that they can put a 6 underneath each of those and just cancel it out. Despite my big frowny faces and whatever, somebody is still going to do this. And I will not give you any partial credit for this mistake. If that's your first step, you can't recover from that. You can't suddenly get points. All right, so number 11, the answer is e to the negative 1/2, in case you're still trying things on your own. The answer to this one is 25 over 3. The answer to the next one is 5. You can try this on your own. So our first step is to get this natural log by itself. So I'm going to subtract 5, which gives me negative 1. And then I'm going to divide by 2. I have an ln in my problem. How do I undo it? With an e. So I exponentiate both sides. So e to the ln of x is equal to e to the negative 1/2. Let that really sink into your head and make it make sense. If the bases are the same, then the exponents have to be the same. On this side, this cancels, and I get e to the negative 1/2, or 1 over e to the positive 1/2, or 1 over the square root of e. Lots of ways to write this answer. On the next one, I'm trying to get the log base 5 by itself. You can't do anything until it's by itself. So I divide by 2, and I get 2. And then I'm going to exponentiate. I have a log base 5, so I need to use a base 5 to make these the same. 5 and 5. And now the original problem is going to be the exponents. That on this side gives me 3x, and on this side gives me 25. I divide by 3, and I get 25/3, or 8 1/3. As always, there's more than one way to express a correct answer. Think about your first step. What do you want your first step to be for number 13? Hopefully, you did not think, oh, they're base 10. She wants to see if I recognize the base 10. Don't do that. Okay, that would be wrong. You cannot do this problem unless you've condensed it. You can only do something to each side. So I'm going to change this to log of 5x times x minus 1. You learned from condensing that if the two logs are being added, you can multiply them. And now the base is a little 10, even though you can't see it. So log of, let's just change that to 5x squared minus 5x, just easier to write, and 10 to the 2. Again, this is the most missed question, so make sure you're following me. And if you're not, come and ask. That's what I'm there for. I see an x squared in my equation. What do? I set it equal to 0, and I factor. And don't forget, the best thing to do is to factor out first. This stands for factor out first. It's a really hard factoring problem like this, but as soon as you take that 5 out, oh, it's just great, because now this has to just be x and x. And like I said, even though there's lots of factors for 20, 9 times out of 10, it's going to be the ones that are closest together. So let's try the 4 and the 5 first. That gives me a 4x and a 5x. And sure enough, if I make the 5 negative and the 4 positive, I can get that negative 1x in the middle. I'm always shooting these loops. I mean, I'm shooting for that middle term. So I'm going to make this negative and this positive. And that gives me either x is equal to negative 4 or x is equal to 5. Now, there is one little thing you have to watch out for. We have not been doing this all along, but I was just trying to concentrate on teaching you how to do the problems. But this is the first one where we actually have something called an extraneous solution. So sometimes you get an answer that doesn't work. You didn't do anything wrong, it just, when you go to plug it back in, it doesn't work. That happens sometimes with square roots, because you get an answer that gives you a negative under the radical, and you can't have negatives underneath the radical. Similarly, you can't take the log of a negative number. Remember that a log graph looks like this. There are no logs of negative numbers. There's nothing over here. So if you put a negative 4 into this problem, you would be saying log of negative 20, which isn't allowed. So the only answer is the 5. Now, I want you to be very careful here. I'm not saying that you can't have a negative answer. I'm saying you can't have a log of a negative number. So if this problem had been log of negative x, you actually would want x to be a negative number. That would be okay. In that case, if you had x is equal to 5, that's the one you'd have to rule out, because you can't take the log of a negative number. So hear me on this. Don't just cross off the negative answer. Cross off the one that creates a negative with a log. All right, a little challenge problem for you. If you'd like to stop the video and try it on your own, I would be so happy about that. But I will do it for you. So on this problem, I'm going to factor. I don't see an x squared, but I see an e squared. So the way you're going to do this is actually e to the x times e to the x. People don't always see this right off. But e to the x times e to the x, remember when we multiply like bases, we add their exponents. So it's not e to the x squared, it's e to the 2x. And then I'm going to break this down the only way I can, which is a 2 and a 1, which gives me 2e to the x and 1e to the x, which would only make negative 3 if they were both negative. So let's see, does that work if I make them both negative? Yep, that would create a positive 2. So it just all around works. You should always refoil to make sure it all around works. So don't overthink this. Just do it the way you've always done it. If you had x plus 4 times x minus 5 is equal to 0, you would say either x is negative 4 or x is 5. You'd set these both equal to 0. It's the same concept. So I'm going to do two little equations. Either e to the x minus 2 is equal to 0, or e to the x is equal to 1. How do I undo an e? With natural log. That's how you undo an e. So natural log and e cancel each other out. I just get x is equal to the natural log of 1, which you may remember is equal to 0. That's one of my answers. On this one, you have to get the e to the x all by itself. Don't forget what you just learned, right? And then I take the natural log of both sides. And on this side, I get x is equal to the natural log of 2. So those are my two answers. In summary, there are 3 methods for solving exponential and logarithmic equations. But for all methods, the first step should always be to simplify the equation as much as possible. Meaning, remember, we added we subtracted 5, we divided by 2. We divided by 2, or we condensed. So condense logs if needed. I mean, that step's not always there. So your one method would be to make the bases the same and use the 1-to-1 property. So if you can make it 2 to the x is equal to 2 to the 5, good for you. You can do it that way. But for the most part, you're going to be using methods 2 and 3, which is for an exponential equation, take the log of both sides, and for a logarithmic equation, exponentiate both sides. Let's do some application problems. Oh, I think there was a little thing there. Maybe it didn't show up. There it is. The last step should always be to check your answer. It could be extraneous. Remember, you can't take the log of a negative number. Oh, just a little warning. Sometimes kids will have an equation with an e in it, and they'll say, when they'll get x is equal to -2, they'll say, oh, that can't be right if you have e to the x. You can have e be to a negative number, just you can't take the log of a negative number. So watch out for that. All right, let's do our word problem applications. So the first one says, the number y of endangered animal species in the United States from 1990 to 2002 can be modeled by this equation. It works for 10 to 22, where t represents the year, t is 1990, and then 22 would be 12 years later, which would be the 2002. During which year did the number of endangered species reach 357? So the question is, does the 357 go in for the y or in for the t? Well, the species is the y and the t is the time, so we're going to put it right there. So the good news is that this is actually just more of what we've been practicing. If you didn't know how to do this problem for some reason before we learned this, what I taught you back a couple days ago was that you could make this your y1 and you could make this your y2 and you could intersect on your graphing calculator. You can still use that method. That's a great method for solving. But some people don't like it because they can't get a good window. So if you were going to do it that way, remember that you want to make sure you go on your x-min. I still start at 0, even though I could start at 10, and go all the way up to 22. And for your y values, you need to go up to at least 357. But again, so you can see it, I'd probably go up to 400 to make sure that you can see it. And since some people don't want to take the time or struggle with plugging these both into their graphing calculator and using the intersect feature and making a good window, now you know how to do this just by algebra. So our first step is to add 119 to both sides. 357 plus 119 is 476. My next step is to divide that by 164, which gives me 2.902. Now, I'm only going to write 2.902, but I have left it on my calculator. Leave entire answer on your calculator. Okay, don't actually round that. And then how do I undo an ln? With an e. So you want to do e to the 2.902. When you're showing me your work, you may round to 3 decimal places, but when you're actually doing it on your calculator, you shouldn't round. Instead, so this side just gives you t. Instead, you can do e to the, and then hit the button that says answer. It is right above the negative key on your calculator. So if you say e to the answer, it'll give you the exact answer. which is 18.21852665, which of course we can round to 3 decimal places, so 18.219. But the question actually says during which year. So we have to correspond 18 to a year. Remember that 1990 represents 10. So if 1990 is 10, then to get 18, we need 8 more years. Right? 10 is 1990. We still need 8 more years. So 1998 is the actual answer. So I go to my y is equal to, and I type in the equation, which was negative. Make sure you don't use the subtract button. 119 plus 164 natural log. I do switch it to x. I never use t. And then I'm going to set it to 357 is my y value. But here's the key. That part's not hard for people, typing the two sides of your equation in. But for your window, they told you that the values are from 10 to 22. I usually go from 0 to 25 or something around it. I don't like to box myself in quite so much. And then from 0, I got to get all the way up to 357. So I'm going to do 400. I hit graph, and I should be able to see it. There's the point of intersection. If you put the right window in, you can see the point of intersection every time. Second, calculate. Intersect is number 5. First curve is that one. So you just hit enter for, like, it's kind of like saying yes. They're saying, is this your second curve? Yes. Would you like to make a guess? I do not. They only intersect once. I can just hit enter. And there it is. Just what we thought, 18. So it's a great method if you'd like to use it. Number 2, the number of trees of a given species per acre is approximated by the model given here, where x is the average diameter of the trees in inches 3 feet above the ground. So they're going to measure these trees 3 feet up, and they're going to look at the diameter, which is all the way across. And they're going to do that at a height of 3 feet. Use the model to approximate the average diameter of the trees in a test plot where n is equal to 21. So again, we're doing these problems backwards. They're telling you n is 21, and they just pretty much want to know if you can solve this. Can you do it on your calculator? Absolutely. So you're going to want to pick a window between 5 and 40 and make this your y1 and this your y2, and look to see where they intersect. If you want to do it by hand, then you would take your 21 and you would divide by 68, which would give you 0.3088. I'm just going to write it that way, but on my calculator, I'm going to leave the whole thing there. 10 to the negative 0.04x. How do I undo an exponent with base 10? I use a log with base 10. 0.04x. And on this side, I'm going to do log, again, base 10, which isn't a button on your calculator. It's just log on your calculator. So then I'm going to say log of the answer. Make sure you're using that answer button, which will use the entire thing, 3.3088235.294. And when I do that, I get negative 0.510. Again, it's a longer answer, but I'm going to leave it on my calculator because I still have more work to do. Divide by negative 0.04. And you can just go straight and hit the divide button. You don't have to retype in the number, and you'll get 12.757. And now you actually can stop with your rounded answer. Okay? If you use 0.309 is equal to 10 to the x, if you actually did take that and you rounded, and you did log of 0.309 is equal to log of 10, actually there's still 0.04x here, negative 0.04x. Then log of 0.309 would be negative 0.510 divided by 0.04 would give me 12.751. And you might be thinking, that really wasn't that different. Well, it depends on what you're doing. If you're a scientist and you want your answers to be correct to the nearest thousandth, you can see that it's not. So if you're moving on to AP next year, if you're in honors, this is going to sound silly, but they won't give you credit for this answer over here if you round along the way. You have to keep using your answer the whole entire thing, and it's only on the very last step that you can round. For this next one, I'd like to do it on the graphing calculator in case that's interesting you and you're not sure how to do it. So it says that the number y of daily fee golf facilities in the United States from 1995 to 2003 can be modeled by, so I go to my y is equal to, and I'm going to write the equation, 4381 plus 1883.6. It does say natural log of t, but I'm going to use natural log of x. It's just easier. There's an X button right there next to the alpha button. And they want to know during which year the number of daily fee golf facilities reached 9,000. So that's going to be my y2. I want to know when this equation is equal to 9,000. So like I said, the hardest part of this for most people is you have to make a window. Now, fortunately, it said that the t, which is our x, ranges from 5 to 13. So I'm going to go from 0 to 15. I like to be able to see a bigger window than the specific thing that I'm looking at. But here's the most important part. It's the number of daily fee golf facilities. It's not going to be negative, so I'm going to go ahead and hit 0. And we want to know when it reaches 9,000. So you're going to see this graph, you're going to have to make it reach 9,000. I'm actually going to go all the way up to 10,000 just to make sure I can see it clearly. And now I can hit graph. There it is. My intersect button is found under this calculate. So second, calculate. Intersect is number 5. My first curve, if yours isn't color-coded, it's also flashing on it, and it also says it up there. So I hit enter, and then it's saying, is this your second curve? It's like a question. Is this your second curve? I know it's a line, not a curve, but that's just how they say it. I say yes, and I don't need to make a guess if there's only one point of intersection. So I just hit enter. And there it is without doing any math at all. I got that the answer is 11.6, which for our problem represents the year. So 11.6, 5 was 1995. So 0 must be 1990. So this must be 2001. That is another hard part of this problem, is converting it to years. So 2001. So the last answer, I'm just going to write it here on the board for you, was 2001. And again, if you didn't quite follow why there, because if 1995 is 5 and 2003 is 13, then you can keep going one at a time, but 11 is going to be 2001. Moving on to number 4. You have deposited $500 in an account that pays 6.75 interest compounded continuously. So right away, I know I need the formula that the amount that you're going to have at the end is your principal times e to the rate times. That's how much money you'll have at the end. So ours will be $500. That's your principal. That's how much you've invested. E. Now remember, on this rate, you got to move that decimal over 2 places, so it's 0.0675. And I want to know how long it takes. T is what I'm trying to find. Well, they can't give you 2 variables, so they must have already told you this side. So you have to do a little thinking on your own here. How long will it take your money to double? So they're looking to see when the amount is how much? When the amount is $1,000. So again, you are welcome to do this on your calculator, but it's not that hard to do by hand. I divide both sides by 500, and I get 2 is equal to e to the 0.0675t. How do I undo an e? With a natural log. natural log of 2 is equal to the natural log of e to the 0.0675t. This cancels on this side. The natural log and e undo each other, and I get 0.0675t. I divide both sides by 0.0675. Natural log of 2 divided by 0.0675. And I get t is equal to 10.269. That's how many years it'll take. Obviously, people don't usually say things like 0.269. You could convert it, 0.269 years, if you wanted to change it to months. Your conversion factor to get rid of the years and change it to months would be that there's 12 months in 1 year. So if you multiply 0.269 times 12, then you'll get 3.228. Now you are trying to make your money double, so you actually have to reach the 3.2. So I would say 10 years and 4 months, even though it'll happen, sometime during that third month. You can say 10 years and 4 months. All right, we just have one left. This is a challenge problem, so it is not required, but I will tell you the two answers in case you are interested in doing it. 303 units for part A, and for part B, 528 units. If you try it and you can't get it, obviously I'm always happy to do it for you in class. This is the end of the chapter. Here are some review problems for you, and I hope you have a great day.